Hey, welcome to Build&AI. I'm Nia, your AI learning guide. Let's get into it.
All right, welcome to this explainer on TypeScript fundamentals. Look, if you've spent any time writing JavaScript, you already know the drill, right? It's incredibly fast, super flexible, but yeah, you also know the absolute agony of unexpected crashes in production. So today, our goal is to completely demystify TypeScript. We're not going to look at it as just some extra syntax you got to memorize. Instead, we're framing it as the ultimate preventative safety net for your code. Let's dive right in. So think about this for a second. How many production bugs could we actually avoid before even running the code? We've all been there. You get that relatable, pull your hair out frustration of a silent JavaScript runtime bug. You know, it runs perfectly on your machine, you deploy it, and boom, a blank screen for the user just because some random property was undefined. What if you could stop a huge percentage of those daily bugs from ever making it to the browser? Well, that's exactly the superpower we're unlocking today. Here's our roadmap for this explainer. We're going to cover 1. JavaScript versus TypeScript. 2. The TypeScript compiler. 3. Basic types and collections. 4. The danger of the any type. And finally, 5. Modeling functions and objects. All right, section 1, JavaScript versus TypeScript, going from silent errors to early warnings. You know, to truly grasp the value here, the absolute best way is just to watch TypeScript catch a real bug that pure JavaScript would completely ignore. Think about a standard typo. In pure JS, accidentally typing something like precoi instead of precio just passes silently, right? It's the exact kind of ridiculous million-dollar typo that leaves your users staring at an undefined price tag at checkout. But with TypeScript, that typo is blocked instantly. You get that beautiful red underline right in your editor before you even try to run the code. It catches the mistake on the spot and even suggests the correct property name. It's like having a pair programmer looking over your shoulder. And here's another one. JavaScript always tries to be helpful by silently coercing strings and math functions, but honestly, that just leads to disastrous hidden nan errors that nobody catches until it's way too late. Sure, passing the string 20 might seem to work, but throw in any other string and the whole thing fails silently. TypeScript, on the other hand, just absolutely blocks invalid contracts. If a function explicitly asks for a number and you try passing a string, no way, it simply will not compile. Moving on to section 2, the TypeScript compiler. Basically, your code's preventative medical checkup. If TypeScript is our safety net, then the compiler, which we know as TSC, is the core engine holding the whole shebang together. Let's look at the exact lifecycle of a line of code. Step 1, you write your .ts files. Step 2, and this is the crucial one, the compiler analyzes and verifies all your types, literally stopping errors right in their tracks. Step 3 generates your standard .js files, and finally, Step 4 executes that code in the browser or Node.js. The absolutely vital takeaway here, the type checking happens completely in Step 2. And because of that, those types actually disappear entirely during compilation. Your runtime code is just plain old JavaScript. So TypeScript analyzes the code and prevents structural bugs before execution, but it does not execute the code itself. Meaning, it's not going to save you from pure runtime logic errors, like dividing by 0 or some unexpected network failure. It's a type checker, not magic. Section 3, Basic Types and Collections, Modeling with Precision. So how do we actually build this safety net? Listen, a massive misconception is that you have to write out types for absolutely everything. You really don't. TypeScript's automatic inference is highly intelligent. If you assign the number 10 to a variable, it instantly knows, okay, that's a number. You really just want to save your manual annotations for when you declare a variable without an initial value or when you need to strictly enforce a function's contract. Seriously, let the inference do the heavy lifting for you. Now, when you're grouping data, you have choices. Standard arrays are open-ended for lists where all items are the exact same type, like, say, a list of user IDs. Their length can change freely, but tuples are strict, fixed-length structures where types are locked by position. They're totally perfect for things like returning a specific status code, followed by a message string from a single function. In a tuple, position matters, and the overall structure is locked in. And if you want to make those collections even safer, we have a wonderfully powerful tool, the read-only modifier. Imagine you're fetching an API config or a list of permissions that should never, ever change during execution. Well, by adding read-only, you literally guarantee the data won't be modified later. It's essentially protecting your codebase from your 2 a.m. highly caffeinated self. The compiler will instantly throw a fit if anyone tries to use push or alter the elements in any way. Section 4, the danger of the any type, the ultimate villain of safety. Okay, so we've built this beautiful, robust safety net, but now we have to talk about the villain that can destroy the whole thing in seconds. What is any? Well, it's a type that completely turns off all compiler verification. When you tell TypeScript a variable is any, you're basically telling the compiler, hey, look the other way. You lose auto-completion, you lose your early warnings, and you allow all potential errors to escape right into production. Using any is literally just returning to the chaotic Wild West of pure JavaScript. When you use any irresponsibly, you're allowing totally invalid operations, like trying to perform math on a string, which causes silent runtime crashes. But fear not, the hero alternative here is unknown. Unknown essentially says, I don't know what this data is yet, but I promise to check before I use it. It forces you to prove what the data is using a safe typo check. This process is called narrowing, and you have to do it before you can safely unlock its properties. It's cautious and it's smart. Now here is a pro tip that you absolutely should take away from this explainer. Modern super-fast bundlers like Vite or Webpack, they prioritize speed, and sometimes they'll actually just transpile your code and completely ignore type errors. So running the command npx_tsc with the no emit flag is your ultimate medical checkup. It asks the compiler to check your entire project strictly for type errors without actually generating any files. It is pure, unadulterated quality control. Use it. All right, our final section, number 5, modeling functions and objects, creating clear contracts. This is really all about establishing strict rules for your complex data so team development stays organized. When you're creating object models, you want to lean on interface for core domain models, like a user or a product. They're super flexible, they can use the extends keyword to grow, and they can merge together, which is absolutely great for scaling. On the flip side, use type for specific aliases, like defining a strict union of literal strings. For example, a status that can only be exactly open, closed, or pending. Also, when you're modeling those objects, you're often going to use the question mark to make a property optional. But beware, marking a property as optional introduces the very distinct possibility that its value will be undefined. But TypeScript is smart enough to flag this. It will force you to use narrowing, basically checking if the value exists first before you can safely interact with it. It totally prevents you from accidentally trying to read a property of undefined. Let's bring it all together with a professional checklist. Your golden rules for your code. To wrap all these core lessons into a routine you can actually use every single day, here are your golden rules for maintaining that robust safety net. First, always use TSC with the no emit flag for real, strict verification. Second, read the full error message. See exactly what was expected versus what was received. Third, never use the any villain just to sweep an error under the rug. Fourth, if you don't know a type yet, rely on the cautious, unknown type instead. And fifth, use interfaces to build scalable, crystal clear models for your core domain entities. So, are you ready to stop guessing and start verifying your code with evidence? Remember, those red squiggly lines in your editor, they aren't annoyances. They are your safety net, catching a fall before your users ever see it. Embrace the compiler, banish any from your codebase, and start writing safer, more reliable code. Thanks so much for joining me on this explainer. Keep building, and I'll catch you on the next one.
And that's a wrap for today. If this lesson was helpful, go ahead and hit that subscribe button so you never miss a new episode. We drop 3 new lessons every single week, all designed to help you learn, build, and launch with AI. Share this with someone who's on the same journey, and I will see you in the next one.